Hi, my name is Leonardo and I'm making this presentation together with Christian Martins. And we're going to talk about code coverage with the Erlang programming language. And to start, I need to explain why I'm doing this video. So testing is a super important thing in software engineering. And testing a program is basically running it with some inputs and then using some tool to find out which parts of the program were executed and which parts were not. And then we get this set of executed code parts, which is called the coverage of the test. So in this video, we're gonna show how to use Erlang's messages to implement a simple test coverage engine. So now let's have a look at message passing. In Erlang, there is no data sharing between processes through memory. So the way that Erlang deals with data sharing between processes is through messages. It works in such a way that each process, it has its own mailbox, and there will be a receive block that will allow the process to do something with the messages from its mailbox. So let's look at the code and see how this is actually done. Inside the process, you first write the destination process of the message, and then the exclamation mark that will be the operator to send messages, and then the data that you're gonna pass in this message. So coming back to our main goal here, we are trying to make this coverage tool. So we need to take a piece of code and we need to interpret it somehow. So the way we are doing it is dealing with this piece of code that will come in a file as a string and then converting it. And we rely on the Erlang programming language to do so. So first of all, we access this file and we grab its data as a string with the read file function, and then we convert it to a list that will be easier for us to handle. After converting it to a list, we convert it then to tokens and then to expressions that after all are going to be evaluated. And we are breaking it into expressions because our main goal here is to have a branch coverage. So branches are pieces of code that can be deviated depending on some condition. So let's take, for instance, an if-else statement. So if the if condition is true, the else is not executed, and vice versa. Thus, there are two branches in an if-else statement. So why is it better to look at branches in terms of test coverage than looking at lines? Because there can be more than one branch in the same line, and if the test reaches just one of them, when there is a line coverage, the coverage tool is going to indicate this line that has three branches as fully covered. But it will actually not be, because there will be parts of this line of code that were not reached. For instance, if the if condition is true, the else would not be reached. So the overall idea is taking branches, instrumenting them, then passing this instrumentation through an engine that's going to give us the covered log. So now seeing a more practical example. So there is this simple if, and so we take it, and for each branch we add this message passing, where the message is going to be sent to itself with the number of the clause that is being executed and the clause itself. So when this instrumented code is executed, it will invoke the receive block that is going to take this data and say that it was executed, and also store in this num variable the number of the clause that has just been executed. And then we take the AST, which stands for abstract syntax tree, that is that way of representing the code divided in expressions. So we take this and we convert it to a list, and then we store this list in this type variable. And with our example here, within the type, the first item is going to be the if, and then the second item from the type variable is going to be the line. So we put this if inside this cond variable, and we put the line inside the line variable. So as in this example, we are just dealing with ifs. As soon as we identify that there is an if, we store the clauses inside the if in this clause list variable, and then we print the clauses. We invoke this function called print clauses that is going to be a recursive function that is going to go through the clauses, see the ones that were executed, the ones that were not, and do the process that we have already explained. And if we do not identify the if, then we just print nothing. So now the print clauses. So when we enter the print clauses, we verify if the current clause is inside the number variable, the num variable. If they are the same, that means that this clause was executed. So then for this clause, we get the fourth item of the list, which is going to be the operation that is going to be done in this clause. And then we get the line that is going to be the second element of the list. And then we print some text with then the operation and the line. And after this processing, we do the print clauses again with the current plus one. So it's going to recursively go to the next item. Then if it's a clause that the num variable is not equals the current, that means that it's something that was not executed. So we just print clause not executed. And then we also invoke the print clauses again, pointing to the next item.